Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. A GFCI monitors the current flowing in the hot and neutral wires of a circuit. If there is an imbalance, meaning some current is leaking to ground, the GFCI quickly trips the circuit, cutting off the power. This happens in a fraction of a second, fast enough to prevent serious injury. Now consider a situation where there's a two-wire circuit already wired with 3-prong outlets, but without a ground wire. There are a couple of ways to approach adding GFCI protection. Firstly, installing a GFCI breaker in the electrical panel. The GFCI breaker monitors the current flow. If an imbalance is detected, indicating a ground fault, the breaker will trip, cutting off power to the entire circuit. This method provides ground fault protection for all the outlets in the circuit, even though they lack a dedicated ground wire. To install a GFCI breaker, follow these steps. 1. Install a GFCI breaker in the panel. 2. Connect the hot and neutral wires of the two-wire circuit to the GFCI breaker. 3. Do not connect an equipment ground wire to the breaker. 4. Leave the equipment ground screw and the outlets unconnected. Secondly, you can install a GFCI outlet at the beginning of the circuit. Replacing the first outlet in the circuit with a GFCI receptacle will protect all downstream outlets. The GFCI outlet will trip if it detects a ground fault, cutting power to all outlets that fall out in the circuit. This method also provides ground fault protection without requiring a ground wire for the downstream outlets. To install a GFCI outlet, follow these steps. 1. Install a GFCI outlet at the beginning of the circuit. 2. Connect the hot, neutral, and ground wires to the GFCI outlet. 3. Install regular 3-prong outlets downstream. 4. Do not connect an equipment ground wire to the downstream outlets. It's crucial to understand the limitations. Neither option provides a true ground connection. While GFCI protection safeguards against ground faults, it doesn't protect against electrical shock or fire hazards caused by direct contact with a live wire. A proper ground wire provides a path for fault current to flow back to the source, tripping the breaker and quickly de-energizing the circuit. Without a ground wire, there's no such path, and the circuit may remain energized even if there's a dangerous fault. While adding GFCI protection to a two-wire circuit is better than nothing, it's recommended to upgrade the circuit to a 3-wire system with a proper ground wire. This provides the most complete protection against electrical hazards. If upgrading the wiring isn't immediately feasible, consider using both a GFCI breaker and GFCI outlets. This provides an extra layer of protection in case one device fails. Remember, electrical work can be dangerous, so it's always best to consult with a qualified electrician if you're not comfortable working with electricity. They can assess the situation, determine the best course of action, and ensure the work is done safely and in compliance with local electrical codes. Also, it's important to regularly test GFCI devices to ensure they're functioning properly. Most GFCI outlets and breakers have a test button that simulates a ground fault. Pressing this button should cause the device to trip. If it doesn't, the device may be faulty and should be replaced. Also, consider arc fault circuit interrupters or SIs. SIs are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. SIs detect arc faults by monitoring the current waveform. Arc faults are characterized by erratic current flow and high-frequency noise. When an SI detects an arc fault, it quickly trips the circuit, cutting off the power and preventing a fire. SIs are required in many new homes and are recommended for older homes as well. They provide an extra layer of protection against electrical fires. Furthermore, surge protection can safeguard against power surges. Power surges are sudden spikes in voltage that can damage electronic equipment. They can be caused by lightning strikes, power outages, or even turning on and off appliances. Surge protectors work by diverting excess voltage away from sensitive electronic components. They are available in various forms, including surge protector strips, whole house surge protectors, and surge protected outlets. Whole house surge protectors are installed at the electrical panel and provide protection for the entire home. Surge protector strips are plugged into outlets and provide protection for individual devices. And in addition to these safety devices, it's essential to follow safe electrical practices. Never overload circuits by plugging too many devices into a single outlet. Use extension cords sparingly and never run them under rugs or furniture. Keep electrical cords away from water and heat sources. And always turn off the power before working on any electrical circuits. By following these safety precautions, you can help prevent electrical accidents and ensure the safety of your home and family. Electrical codes and regulations are constantly evolving to improve safety. Stay informed about the latest requirements and consult with a qualified electrician to ensure your electrical system meets current standards. Proper grounding is a critical aspect of electrical safety. A ground wire provides a low resistance path for fault current to flow back to the source, tripping the breaker and quickly de-energizing the circuit. Without a ground wire, fault current can flow through other paths, such as through a person's body, causing electrical shock. The size of the ground wire must be appropriate for the size of the circuit. The National Electrical Code, or NEC, specifies the minimum size of ground wire required for different circuit sizes. Ground wires must be properly connected to the grounding electrode system, which typically consists of a ground rod or ground plate buried in the earth. The grounding electrode system provides a connection to the earth which helps to stabilize voltage and provide a path for fault current to flow. In addition to ground wires, bonding is also important for electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a common electrical potential. This helps to prevent voltage differences between metal parts which can cause electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect metal parts together. Bonding jumpers must be properly sized and connected to ensure a good electrical connection. Electrical panels are the heart of an electrical system. They distribute power to the various circuits in a building. Electrical panels must be properly sized to handle the electrical load of the building. The size of the electrical panel is determined by the total amperage of all the circuits in the building. Electrical panels must be properly grounded and bonded to ensure electrical safety. The panel must be connected to the grounding electrode system, and all metal parts of the panel must be bonded together. Electrical panels should be inspected regularly to ensure they are in good condition. Look for signs of damage, such as corrosion, loose wires, or burnt components. If any damage is found, the panel should be repaired or replaced by a qualified electrician. Wiring methods play a significant role in electrical safety. The NEC specifies the types of wiring methods that are permitted for different applications. Some common wiring methods include non-metallic sheathed cable, or NM cable, electrical metallic tubing, or EMT, and rigid metal conduit, or RMC. NM cable is commonly used for residential wiring. It consists of two or more insulated conductors enclosed in a non-metallic sheath. EMT is a thin-walled steel conduit that is used for both residential and commercial wiring. RMC is a thick-walled steel conduit that is used for heavy-duty applications. The choice of wiring method depends on the application and the environment. For example, EMT or RMC may be required in areas where the wiring is exposed to physical damage. Electrical boxes are used to enclose electrical connections. They provide a safe and secure place to make connections and protect the connections from damage. Electrical boxes are available in various sizes and shapes to accommodate different types of wiring and devices. Electrical boxes must be properly grounded and bonded to ensure electrical safety. The box must be connected to the grounding system, and all metal parts of the box must be bonded together. Electrical boxes should be sized appropriately for the number of wires and devices they contain. Overcrowding can lead to overheating and electrical hazards. The electrical codes and standards are developed to ensure electrical safety. The NEC is the most widely adopted electrical code in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. State and local governments may also have their own electrical codes, which must be followed. Electrical codes and standards are enforced by electrical inspectors who inspect electrical installations to ensure they comply with the code. Electrical inspectors can issue citations for violations of the code and can require that the violations be corrected. Electrical safety training is essential for anyone who works with electricity. Electrical safety training teaches workers how to identify electrical hazards and how to work safely around electricity. Electrical safety training is required for many occupations, such as electricians, linemen, and maintenance workers. Electrical safety training should cover topics such as electrical hazards, lockout/tagout procedures, personal protective equipment, and first aid. Electrical safety audits are conducted to identify potential electrical hazards in the workplace. Electrical safety audits are typically conducted by qualified electrical safety professionals. Electrical safety audits can help to identify and correct electrical hazards before they cause accidents. Electrical safety programs are comprehensive plans that address all aspects of electrical safety in the workplace. Electrical safety programs should include policies and procedures for electrical safety, training programs, and audit procedures. Electrical safety programs should be reviewed and updated regularly to ensure they are effective. The importance of electrical safety cannot be overstated. Electricity is a powerful force that can cause serious injury or death if not handled properly. By following safe electrical practices and using appropriate safety equipment, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. Electricity travels in closed loops, flowing from the source through the circuit and back to the source. A break in the loop can cause a circuit to stop working. Electrical circuits are designed to carry a specific amount of current. Overloading a circuit can cause it to overheat and potentially start a fire. Always use the correct size wire and breaker for the circuit. Electrical devices should be used only for their intended purpose. Using a device for a purpose other than what it was designed for can be dangerous. Always read the manufacturer's instructions before using an electrical device. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical repair should be performed by a qualified electrician. Before working on any electrical circuit, always turn off the power at the breaker box. Use a voltage tester to verify that the power is off before touching any wires. Always wear appropriate personal protective equipment, such as gloves and safety glasses, when working with electricity. Never work on electrical equipment in wet or damp conditions. Water is a conductor of electricity and can increase the risk of electrical shock. Be aware of overhead power lines when working outdoors. Maintain a safe distance from power lines to avoid electrical shock. Call your local utility company before digging near underground utilities. They can mark the location of underground cables and pipes to prevent damage and injury. If you see a down power line, stay away from it and call your local utility company immediately. Downed power lines can be extremely dangerous. Teach children about electrical safety. Explain the dangers of electricity and teach them how to avoid electrical hazards. Supervise children when they are using electrical devices. Make sure they understand how to use the devices safely. Regularly inspect your electrical system for signs of damage or wear. Look for frayed wires, cracked outlets, and loose connections. If you find any problems, have them repaired by a qualified electrician. Keep electrical panels and outlets clear of obstructions. Do not block access to electrical panels or outlets. Use outlet covers to protect children from electrical shock. Outlet covers prevent children from inserting objects into electrical outlets. Install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoors. GFCIs protect against electrical shock by detecting ground faults. Install arc fault circuit interrupters, or RSIs, to protect against electrical fires. RSIs detect arc faults, which are a common cause of electrical fires. Consider a whole house surge protector to protect your electronic equipment from power surges. Power surges can damage or destroy electronic equipment. Have your electrical system inspected by a qualified electrician every few years. A professional inspection can identify potential problems before they become serious hazards. Electrical safety is everyone's responsibility. By following safe practices and being aware of potential hazards, you can help to prevent electrical accidents and ensure the safety of yourself and others. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.